Now what we're going to do is work out an area using the area scale factor. Okay, now first thing you have to do is just work out the linear scale factor. So you've got two shapes here. One shape you know everything about, so we're going to call that's the old. And next shape, there's something missing, so that's called new. Okay, so we're going to say the linear scale factor is equal to new over old. Now, what we've got here is we've got a shape that's smaller, okay? So it's going to have an area that's less, okay? Now, we're going to actually work out the linear scale factor first. So we're going to take a side in which, in both shape, we know values for. So we actually, the bottom of it, the base, we know that's 18 and that's 12, okay? So the new is 12, old is 18, okay? Then just bung that in a wee calculator. So that is 12 divided by 18, and that is, again, that's 2/3. Okay, so just have it as 2/3, okay, because the fraction's more precise than a decimal. Now, what we have to think about, if you work out area, okay, it's like squared centimetres. So what we're going to do is we're going to say that area scale factor is the linear scale factor, but we just square it. Okay, so what we've got here is we've got area scale factor, and that is going to actually be just 4/9. Okay, because that is this squared. Okay, so if I actually just square that, if I can work out how you work this calculator, I think I can go into scientific. So that's 2 divided by 3, and then we can square it. Okay, so keeping that as a fraction, so I've just really squared the numerator and squared the denominator. So to actually work out A centimetres, all we do here is we then just say, what's A? I should actually be precise. A square centimetre is equal to your area scale factor, or you can just say linear scale factor squared, times 135. Okay, and that equals, so if I get the calculator, so I'm going to move it so you can see it, 135, just going to say that's going to be 4/9 times 135, divide that by 9, times a whole lot by 4, and that's going to give me, the area is going to be 60 square centimetres. So you work out the linear scale factor. With area, the value is squared, so you then square the linear scale factor, and that gives you the area scale factor. And to work out the missing unknown, you basically get the corresponding value of the other shape that you know everything about, and you just times it by the area scale factor. Okay, so that area scale factor again is the linear scale factor squared. With this one, what we've got, again, we'll work at the linear scale factor. Okay, it's new over old. So we're going to call this one new because we don't know everything about it, and old because we know everything about it. So new over old is 28 divided by 21. Okay, so I'll go 28, I'll divide that by 21. Okay, say that's 1 1/3. Okay, so that's as a mixed number. Now, that is bigger than obviously 1, so that is why you've actually got a bigger shape. Okay, that was smaller than 1, so that's why it's a smaller shape. So your area scale factor, okay, is 4/3. That's squared. So I've just put this into an improper fraction. So that's 16/9. Okay, so this f centimetre, or f square centimetre, that is going to be 16/9, because that's area scale factor, and that's going to times 180. So I'll get the calculator out. What we'll do here is I'm just going to say that's 16 times 180, and then I'm just going to divide that by 9. Okay, and I've got an area of 320 square centimeters. Okay, so again, I'm just doing this as a shortcut. So 4 squared was 16, 3 squared is 9. Okay, so that's essentially gives you a value that's bigger, which it should be bigger because it's a larger shape. That value is smaller, which it should be smaller because it's a smaller shape. So it's always good just to take a wee step back and just to make sure that if it's a bigger area, then the area scale factor should be bigger than 1. If it's a small area, then area scale factor should be smaller than 1.